Our next speaker is Hardouin from Orange. He is Director of Ambient Connectivity Research Area at Orange Labs.
Okay, good morning or good afternoon, I'm not sure, everyone. So in this talk, we will provide our views on future networks. And on purpose, there is no 6G here. We will see later if this goes into 6G or some 5G evolution. But anyway, doesn't really matter for my talk. What is important is that we share what we think networks in the future should deliver. And I like very much what Peter said this morning about the fact that technology needs to solve some problems for the humans, some problems for the society. And so with that respect, it's interesting to have a look to what are the things that we see coming for the future that will that will affect the society and that will either provide some problems for the networks to solve, or that will provide constraints also about how we need to deploy the networks. And the first one is, of course, in our view at least, the energy efficiency and the environmental responsibility. And this has been addressed by a number of speakers earlier this morning. Then we need to support increasing the productivity of our industry, of our agriculture as well, because as we know, feeding the growing population on Earth will also be one of the major stakes in the future. Improving the efficiency of public services, communities, cities, this is something that will be also extremely important in the future. We have mentioned also previously this morning the strong need for security, privacy, and sovereignty, because networks, as we will see later, are becoming more and more strong assets of the countries, because they will run more and more critical applications. And in the end, networks can also provide more quality time for individuals, which involves automating all the human tasks that can be automated, and also providing more opportunities for entertainment. So of course, many of those aspects have already started to be addressed by 4G. 5G will continue and enhance this trend, but there are still many things that we can do to further improve those directions. And then when we project ourselves into the future, we need also to be very humble, because there are many things that we cannot predict today, but still will be important drivers in the future society. And still the technology that we will start to design these days will need to cope with this unknown. So technology needs to fulfill some usages. So usages are driving the way we should define technology. And with 5G, we have started a very good movement, which is to engage with the future users of our networks. Individuals, but also the big change in 5G is that we have started to discuss with vertical industries. And this is a move that we need to continue and to expand, especially if with future technologies we will have new types of users. We also need to understand what will be their needs, because of course it's not the same of deploying a network to deliver 1 millisecond everywhere or to deliver 20 milliseconds everywhere. And we as operators, we need to understand what is really required, because we don't want to over-design our network, because in the end, someone will have to pay. That can be us, that can be the customer, but someone will have to pay. Then we have, with 5G, we are launching also some disruptive services, those low latency, high reliability services, but also from the network design part, we are going into virtualization of the networks, which is a really big change for us, operators. And before going far into those directions, we have heard today some requirements of 0.1 millisecond, for instance, then it would be useful to first get some feedback about how those technologies, they really work on the field, on how much they are adopted also by the end users. Because we believe in those technologies, but having the reality test is extremely important if we want to project ourselves into some longer-term technologies evolutions. So usages are a very important point. Another one is money, because as you know, deploying networks is extremely costly. And as has been also pointed out by speakers before me, revenues are not increasing for operators. The data rate, the amount of traffic is increasing, but not the revenues. That means that if we want to keep our economic viability, we need to reduce our costs. That means that we have a heavy pressure on CapEx those days. And when we think about the future technologies, you can rule out all the things which will be costly because operators in the future, unless we find new sources of revenues, and going towards the industry is one potential source of revenue. But still, if we need to invest, then we need to have some hope for return for investment. Otherwise, we cannot invest. So there are uncertainties about how the society will evolve, what will be expected from the networks. There are uncertainties also about what will be the future usages, but there are things that are clear. The first one is that we are going to move from having essential connectivity to critical connectivity. Critical because if we have power plants who are depending on network for ensuring the protection of the installation, network is critical. If there is a network failure, there will be a shortcut of electricity supply. And that is true also for many other aspects of our industry. So that calls for having trustable networks. Trustable in the sense that they are secure and they are resilient. If they break down, then there is a need for some prediction that a problem will happen, so that we can also inform the users of the network so that they can take the appropriate measures to have some safety on their own business. So building trust is extremely important, also if we want technology to be adopted by those future users. Another big change is that so far we have focused on covering the population. Most of the rules associated with spectrum allocation is about covering a certain amount of the population. Now, especially with IoT, we are moving rather to providing ubiquitous coverage. We want to cover fields, like on this picture, where there is very few people, but still, if we want to have sensors to measure how the Earth is, then we need to have some connectivity there. And that is true also for other aspects. And coverage is not only a matter of technology, it's a matter of investment, and it's a matter of how you arrange with others to deploy the networks. So there was a question before about how operators can share the investment, and that's a possible way. When there is no competition, when there are low revenues, infrastructure sharing makes sense. Then you can also imagine to have agreements with some vertical players, for instance. Okay, we want to cover one plant somewhere where there is no one. Okay, then we can co-invest there. But we need to have some new deployment models. But technology can also bring some answers there. If you can extend the range of the cells, then the cost of the network will be lower for a given coverage. Another direction is that with the virtualization, we are moving our network infrastructure into an infrastructure capable of also hosting data and running third-party applications. So it's rather a cloud-like infrastructure. And that allows us to provide new business proposals to our customers. Not connectivity only anymore, but connectivity plus storage, plus compute. Then one thing that has not been mentioned so far is the problem of electromagnetic field exposure. You may know that there are some cities which are defining much more aggressive limits for EMF than the international regulations. Examples include Paris or Brussels, where we have operation. And I can tell you that deploying 5G in those cities is already tough. We need to think a lot. It's not about just putting the base station, turning it on. No. We need to think a lot about reducing power, especially, or doing some other tricks to be able to cope with those limits. And that's only for the C-band. I'm not even talking about the 26 gigahertz band, not even the terahertz spectrum. So if we want to be able to deploy new bands into the future, we need to have a technology that is aware of the EMF it produces and that can lower the exposure. We talked about energy efficiency, and it has been taken into account, and we are very happy about it in the initial 5G design. But we need to think about another aspect about sustainable growth of our industry. It's about the heavy use that we are making about rare earth material. And those materials, they are rare, they are expensive, and especially because it is costly to extract them. And that will not improve in the future. It will be more and more costly to get access to those materials. That means that we need to think also about recycling the products so that we can reuse those rare materials. So I'm not sure whether that's really a research issue, but for sure, I think we think that when now we are building hardware equipment, we need to think also from the design how we are going to recycle those material after the product is removed from the network. And the last point is about inclusion, and I was very happy about the presentation from Sudhir yesterday, because we think that as networks and connectivity become more and more important for the society, we need to ensure that everyone can have access to it. And here I'm not talking about gigabit per second data rates, just basic internet access. That is true for emerging countries. As in Orange, we have a lot of operation in Africa, for instance, where there is no 4G connectivity everywhere, sometimes not even 2G connectivity everywhere. But it is true also in our developed countries, where we have a fraction of the population who is kept away from connectivity, from networks, from internet, because either they have no money for buying the necessary equipment, the necessary subscription, or they just don't know how to use it. And there I'm thinking particularly to the elderly. And so here again, technology can help by reducing the costs of the networks for providing basic internet access. But that's not only a matter of technology, it's also a matter of public policies to make sure that there are programs to help everyone to access the internet. So our vision about the future network is that, of course, it will provide connectivity, but it will also provide computing power everywhere. And with some more details, beyond the traditional things that are not so traditional because we are starting in 5G to address them, but connecting extremely large number of devices with very different requirements, including critical requirements. Still being able to collect and transport massive amounts of data. Yes, but we need to do it in a smart way because as we have more and more traffic into our network, we need also to find ways to keep some data in some places and not forwarding them everywhere. And edge cloud can be a solution for that, to save the capacity on our backbone links, which is also something which has a cost. Trust, security, dependability of the network is something which is very important, but what I didn't say earlier, but is also extremely important to understand, is that in the future, the networks, they will be multi-tenant. If you want to connect a factory which has some moving vehicles between different sites, for instance, there will be a mixture about having a local network inside the buildings together with the public network for the outside. And the global infrastructure will need to be resilient, but still there will be parts that will be run by the operator, parts that may be run by the factory owner, and still the global system will need to be secure and resilient. So how do you ensure that this system will be trustable if it's run by different parties, based potentially on different suppliers? That's a problem that we need to address. So EMF-aware, efficient in energy and natural resource, present everywhere it matters. It doesn't mean necessarily everywhere, but everywhere we need it. Maybe in the middle of the ocean, it's not that useful. Maybe it is. Geographical and social inclusion and CapEx-friendly are key requirements for us in the future network. So now some examples of candidate techniques for future networks, and several of them have been already discussed. And I have a few slides about some particular ones later on. So I will just focus on the ones which are in this list, but not in either discussed in previous presentations or not in the slides later on. We think that there is some potential to move some of the network intelligence into the devices. Yes, there are problems about battery limitations and so on, but the device, in our views, has the potential to become a complete infrastructure element for connectivity, but also for cloud, processing capability. But we think that this should be under the operator control because we don't want the device to mess with the global quality of the network. We have not spoken too much this morning about what we can do for the low bands. For the low bands, we have some power in the device for running advanced receivers, for instance, which we think the potential has not been fully exploited so far. But still, the low bands, they are very rare, but they are also very efficient, so we need to make the most out of them. So any interference management techniques that can be applicable to those low bands is highly beneficial in our view. Then we have said also that in the future there will be vast capacity improvements. But there's also one way that we can think of is how to work with the application developers to limit all the unnecessary traffic that they are generating by sometimes poor design. Limiting the number of traffic from the application is also a way to have more efficient networks and service in the end to our customers. And the last point is the unification of the cloud and the network infrastructure. Yes, the infrastructure of the network in the future will be cloud-based, but still, at least in the first years, we will have separated infrastructure for cloud service and distributed cloud service and network service. But at some point, it could be good to have just a single one. How much time do I have left? Okay. So terahertz spectrum, I will not explain that again, just to point that the European Commission is currently funding 6 research projects on this topic, including one which is a European Union and Japan collaboration. And Orange is the leader of the Vortex project, which is one of those 6 projects. Okay, now 2 cool, in my views, innovations that we can think about. The first one is distributed MIMO or spatial focusing for EMF-aware transmission. It's basically MIMO, except that you put the antennas far apart so that you can create really focused beams, like the red part here, where you have energy just in one point in the network, but not otherwise. And that's very good for having some EMF-aware transmission. And we have run some experimentations with Bell Labs in particular recently on that. So that works on the field. And in the picture, just in case you are wondering, you can see that the antennas, they are on the same line. But of course, if this is because we have obstacles in the environment, this is an indoor experiment. If we would be outdoor, then we would need to distribute those antennas around. One more, how to communicate without energy at all. We can do that, actually. It's about recycling the waves which are already present in the environment. And we can also power the device by some solar, for instance, energy source. So we have a prototype that does all that, and it will be demonstrated in the next Infocom conference. So if you happen to be there in Paris, you will be able to see the demo. The way it works is that you have a tag. So here, it doesn't seem to work. Well, anyway, you have the tag that can, that's the white part here on the figure, that can very simply just distort the waves which are sent by some other source, like in this example. And then the receiver just detects whether there is a perturbation or not, and that you associate that with a 0 or a 1. No perturbation 0, perturbation 1, and so on and so on. So it's very simple, but it works. Of course, it's for very low data rates. We run an experiment in the high-speed train between Paris and Lyon in France, and we showed it works. It was for 300 bits per second, so very low rate, but for some IoT application, it can work. So one question now, all those innovations and all those problems that I have indicated, will they be solved in some 5G evolutions or 6G? Well, it depends. We know that 5G has been designed to be very flexible and to be able to accommodate new techniques in the future. So what will be the technical foundations that will prevent us to add new innovations into the 5G system? This is one question in order to justify going to a new generation. Also, we think that, of course, now is the right time to start the research on future networks evolutions. But when it comes to industrial plans, then we need to be careful, because we should embark into setting the industrial foundation for a new generation only when we have a reasonable confidence about the fact that we are going to define a meaningful technology, so a technology that will provide benefits to real users, and also that when it will be sustainable or beneficial from a business perspective. And some hints there to help doing that is to first get feedback from the operation of 5G commercial networks. Also identify the practical needs and the business cases that we cannot address with 5G in order to justify operators to make investment in this new technology. And also one thing which is important is that we need also to make time for having unconstrained research so that we don't miss any new disruption that may pop up in the next years and that we would miss if we start too soon to build the foundations for a 6G. So now if we adapt what has been the roadmap of 5G to the 6G with the target of deploying in 2030, that would give approximately this. So first, like METIS project for 6G, launched in 2022, and then initial study item in 3GPP in 2026, for first a specification release in 2028. So that's my last slide. So beyond the performance aspects that are obvious for each new technology evolution, we think first about improving the throughput, now reducing the latency, improving the reliability. But beyond that, we think that the research on future networks needs to work on building trust and resilience, especially in multi-tenant deployments. We need to have EMF-aware transmissions. We need to mind the energy consumption and also the natural resource usage. And we need to think also in terms of digital inclusion. If there is a 6G, it should be for everyone. And we hope seriously that 5G will be also for everyone. We need to keep a balance when it comes to research between long-term research, like 6G-like research, but also mid-term research. We have seen, especially yesterday, that there is still a lot of room for improving the 5G technology. And we think that we need very much the academic colleagues to work also on 5G evolution problems. As we said, we think that from the industry perspective, we should not start 6G discussions before 2025, more or less. And I would like to conclude with some remarks about the way we do research. We can see that the complexity of networks is growing exponentially. We have multi-level optimization requirements, and we need still to build systems that will be able to manage everything. That means that now we need really to think in terms of system-level research. Having a very efficient single building block is not enough if it doesn't work properly with the other building blocks around. And it could be better to have a system which is made of, I would say, average performing building blocks that as a whole deliver an extremely good performance than having an excellent channel coding, for instance, on an excellent modulation, but that doesn't integrate well with the rest of the system. And the very last point is that we have now tools to help us achieving this objective. As you know, we have now the possibility to run experiments using PCs. You can set up a network just with some PCs and some RF cards using, for instance, the open air interface. And we in Orange, we have developed our plugin platform that leverages on this, and that allows to directly test innovations from the lab to the field. And I will stop here. Thank you very much.
You mentioned that hugely increasing capex is one of the bottlenecks for operators with 5G and eventually the next Gs. And there's also at the same time there's huge pressure from governments and societies to make development fast. So isn't this then not a technical problem, but isn't it an ecosystemic problem? And shouldn't we think about how the overall current operator-centric ecosystem should be modified to make sure that we deliver the needed services for society and businesses fast enough?
Yeah, I totally agree. This is not only a technical issue. I mean, technique can help, but it's not only a technical issue. And you said that governments want to have accelerations of faster and faster technology deployment, but the problem is that governments have no money. So there are ways still. In France, for instance, we had last year what we call the New Deal. The New Deal is an agreement that the French operators had with the French government for covering the white zones. So the zones in France which are very poorly covered because there are very few people who are living there. And the deal was that because we are supposed to add the frequency licenses renewal in I don't remember if it was 2020 or 2022, but anyway, and we were supposed normally to pay to get a new access to those frequencies that we are using already. And the deal with the government was that you don't have to pay to renew the licenses, they will just continue as before, but in exchange you need to invest all together to deploy radio sites to cover the zones which are not covered. And that is an amount of, in total, 7,000 sites for the whole France. And that was a way to, for the government to abandon taxes money to transfer it to investment to cover the population.
Maybe we can take one quick question.
So just to follow up on the comment and question that Matti asked and you mentioned earlier about the capex that is involved in providing coverage and so on and so forth for the new type of services that we are looking at. I'd like to hear from Orange, especially you, being an operator. What do you see is the role of the micro operators, working closely with the third parties who would provide the infrastructure, but make it attractive enough for them to be a player from the revenue and profitability perspective. So I'd like to hear your comment on extending the role beyond just being a main operator, but involving others to provide the infrastructure and address that problem of capex, and at the same time meet the local needs as well, that micro operators will be better positioned to serve.
Yeah, so micro operator is an interesting concept. This is something that we are studying for Africa. So we have a research project which is exploring those possibilities. And yes, this is something that we can consider. So the idea would be that we would provide, we would have one customer who would be ready to install in his home, for instance, on the roof of his house, some radio site. And in exchange for that, he would get some benefits from us, some help. And in exchange, he would cover the zone around his home. And so this is something that, yes, we are studying.
Thank you, Eric, once more.
Thank you.